Good morning. This video was being made in connection with a question I got from a student, a very good, insightful question. They asked, since we're living in a world in which we can run web apps on our mobile device, our iOS or our Android, why do we still need to study courses like dedicated iOS Xcode development or Kotlin Android development? So I wrote an article here that I'll kick out a link to, but some of these concepts might be a little bit tricky to grasp by just reading about them. So I'm going to take a couple of minutes to try and share some of the key concepts now, so pay attention. If I'm going too fast, you can just replay the video, or of course you can always just ask me, email me or ping me in the comments or whatever. So a couple of factors now. So here's the basic question. There is your mobile device, right? So that could be iOS, Android, or maybe some IoT, Internet of Things device. And we can do, in fact, we have a course called Developing Web Applications for the Mobile Device. So you could just go with a HTML solution, right? So you could write HTML code, and the user could use the browser on the mobile device to access it. The other way we can do it now, which is sort of what the student was asking about, is why do we need device specific? So why do we need Xcode, iOS, or Android Kotlin? And you need to understand a little bit of the backstory to make sense of this, which I will now develop. Now, there's two factors in play. Basically, the high level simple explanation is that when you're doing things at school, there's factors you don't really consider, such as legal and licensing. And there is also long term product support. So, to understand these two factors, let's dig more into this issue about what happens when you write a mobile app with HTML. Well, if you're working on Android, it is less of a problem because Android is open source. And the thing in particular, which is open source, which we care about, is called the memory map. Now, here's a concept that I think students today aren't really being taught enough about, which is the alchemy of how we go from code to accessing a hardware device. So, memory map. And of course, there's also the case now of iOS Xcode. Now, for iOS, Apple keeps the memory map proprietary. It's a secret. They don't really share it out. And of course, for Android, it's open source, so that's not a problem. You can go to the Android developer website, download all the documentation. You don't even need, you know, IntelliJ or any of these Android Studio or anything. You don't really need them to write your Android app. All you really need is a notepad and a Java compiler and access to the Android X libraries. That would be enough. Whereas with iOS, you do need Xcode because Xcode buys you access to this secret memory map. Now, there is a way to get around that, and this is what the student was asking about, I think, which is Apache Cordoba. Apache Cordoba. Now, remember this term here, memory map. The memory map solves the problem, the alchemy of getting you from code to hardware devices. And in fact, I've written a book about it that I'm going to share out. So this link to, whoops, that's the one for Xcode. I'll share that out as well. But the one here, I think it's chapter 3 or something where I talk about it. Yeah, here, chapter 5. So you can go and read that. That'll go into more details. But the essential thing here is the memory map is well, it's a table basically. I go into more detail in this article. But the memory map is a table which relates, it connects hardware devices such as the phone, GPS sensor, or the shake sensor or the tilt sensor. Your phone has dozens of hardware devices embedded on the motherboard. And over here, you're writing code, maybe Swift, or you might be going an old school and writing Objective C, or you might be working on Android Kotlin. In any event, when I'm writing my code over here, my code knows because the person who wrote the language or the compiler or the device drivers had access to this memory map. So in the case of iOS, Xcode knows, and in the iOS programming stack, it has access to device drivers. So device drivers are Objective-C in Xcode, or they are GNDI, Java Native Device Interface files in Java Android Kotlin. These device drivers are little programs that basically they do two things. They work like this. So a device driver is a little standalone program right? Either Java Native Device Interface in Android Kotlin or Objective-C in Swift iOS. So it exposes APIs. So I can call this device driver by programming mechanisms appropriate for Swift or Java. I load and I call the device driver, and now I can call APIs on the device driver. So that's sort of my point of connection as a programmer. That's me, programmer, writing the code, calls the device driver. And then on the other side of the device driver, it reaches out. It uses ultimately hex and binary code, numeric addresses in digital binary. It knows that your phone, for example, or your camera, for example, is available as an electronic hardware device on the motherboard at a certain address. And of course, the camera, as we're going to see, has a number of control points. You can take a picture. In some cases, you can zoom, you can adjust the light or the contrast. You can do various things with the camera. But simply, you can cause it to take a picture and then store that image in the gallery or whatever you want to do with it. So you as the programmer or other programs in your technology stack go through this device driver. Device driver goes to device. Device returns its result, and it makes that available to whoever wants to consume it. So now please remember this concept of the device driver. Now remember a minute ago we were talking about the memory map. So the memory map is the list of those addresses. This is the memory map right here. The memory map is a table, a lookup table, which knows that if I want to go to the camera, I go ultimately to 100010000, whatever's the right value for the system control bus on your motherboard of your phone. And once I've made the connection, I can send control signals and I can receive data back. So device driver, based on memory map. Go and watch the section again or read it in my textbook or my blog if you need to get strong on that. And now let's go and see how this relates to why we would prefer to write a native device specific solution using Android Kotlin or iOS Xcode more than we would prefer to write HTML and serve it up as a mobile web app. So let's look sort of at the worst case in a sense, or the most demanding case, which is I'm on iOS, secret, proprietary. They don't want to share with the world. They want to keep it all secret. And they have good reasons for that, right? Because if you want to get your app into the App Store, it must be written with their official technology stack. You can't use any of these public APIs, which are sort of the watered down version that you use in Cordova. And they ensure quality and they ensure that all iOS apps have a consistent look and feel. And they ensure that they behave well, they play with other apps, they respect the memory space boundaries, they don't step on each other's program space and cause crashes. Whereas a lot of those things can happen in Android because Android is the Wild West. The only thing you need to become certified as an Android developer is $25 to go and register on your website, and then you're free to post apps, and other people are free to download them and use them or not, depending on how good a job you did. But anyway, iOS does enforcement of procedure because it wants to keep things that are top quality. So let's say now that I want to write for the iPhone, but I don't want to use the official technology stack. I don't want to use this. Why I wouldn't want to use it, I don't really know, but just pretend. So in that case, I could use something like Apache Cordova. Spell it again. Or I think that's it. Now, Apache Cordova is a library which basically does the job. It provides open source native device bridges to your application code. So Apache Cordova is an open source mobile app development framework, allows developers to create hybrid. That means run once, run anywhere. So I write the HTML and then I can run it on iOS or Android. It enables the creation of cross-platform applications that can target multiple platforms. Now, the key thing I want you to know about this for right now, for the sake of this question, is this works. And by now, hopefully, you're wondering how it's possible that if I'm writing HTML, I'm going to get to my device hardware location like GPS or phone or a camera. Because Apple has released a sort of a watered down, a simplified set of public iOS APIs, which grant you some access, and that's what Cordova does. It uses these, it grants you some access to the hardware devices of your device. Now, I haven't looked into the history of why this is, and if any of you guys watching this want to go and do that and then post your research in the comments, but I'm guessing the reason they probably did this goes back to the 1980s. In 1987, 88, when computers were a new thing and people were figuring out the rules, some vendors of software, like I remember there was this word processor, I think it was called Word Perfect or something, they kept their data standard, their data format standard confidential. So a lot of users for a year or two would, the office would put all their stuff in this word processor, and then they wanted to migrate to Microsoft Word or something else, and they couldn't because they could not get their own data out of WordPerfect. And there was a big court case that went to the Supreme Court. I remember reading about it in the late 80s. And the decision was made, and there was actually a court ruling that software vendors may not lock or sort of put users in jail in the sense of locking them into their own product. That's actually federal law in the United States, and I'm guessing probably Canada and Europe as well, that if you make a software, the user owns the data and the user has to be able to export that data wherever they want. And that's why even today, if you go to Microsoft Word, you can export your data in XML format, for example, which can be imported anywhere. So I'm guessing the reason they probably did this was to get around that court ruling that says you cannot, if somebody buys the hardware, they're free to do whatever they want with it. You cannot enforce the user to go out and use a certain technology stack to program the hardware they own. So they probably release these public iOS APIs for that reason. And they work in a sense, but they're not that good. And if you've tried programming with Cordoba, you understand what I say. So, anyway, that's one reason. So, now the original question we started discussing was why is there still a focus on creating device specific solutions, Xcode for iOS, Android Kotlin for Android? Why do we do that even though we could do this? And one reason is, and for, by the way, this problem is not really in existence for Android because Android, anybody, you can or I can, anybody can go to the Android documentation site, and if you want to spend enough time, and if you have some skill in assembler language and hardware machine level programming, it's not hard to do that. Having said that, there's also no reason to do it because you could just go and use the Android X libraries anyway. But if you really wanted to just spin your own in HTML, you could do that. With iOS, you can, but it's not a very satisfactory solution. So remember what we talked about now, device drivers and the memory map. That's about that. Now, there's another factor which is not a technology related factor, which I will now address. And that has to do with something that students in college, right, doing your college projects, you don't really get a grasp of how important this is. But when you're at work, you're going to realize that it's very important. Product support and also legal and licensing factors. So even things like having the terms and conditions, your end user license agreement, and so on, OILA end user license agreement, and even things like your copyright statement and the colors. I remember when I was working at the lab, there was the project manager when we were just getting ready to go GA with a new product, a new version of something. They would come around and check we were using exactly the right trademark, exactly the right wording, even the exact right color. Apparently, there's an IBM shade of blue, and he told me if we don't use that exact thing, then the product could be, not protected under copyright. So legal and licensing issues, and also product support. Now, imagine that you have made a product which is a pretty good product. It's a nice and powerful product, and it gets really popular. And then iOS changes their memory map. Is Apache Cordoba going to go and update their driver? Well, you're not paying for the product, so you don't really have an entitlement to any particular level of support. So you can imagine that could be a real problem. If you have a product counting on Apache Cordoba and your hardware base changes and now the product stops working, you have a real problem because Apache Cordoba is volunteers, as I understand, so they'll update it when they get around to it. But you could find yourself in the situation of having to support a product that you can't support because the technology stack is well, it's not supported. Whereas if you use the vendor's tools, iOS, Apple or Android is always going to make sure that their tools support their current version. In fact, in the Android class we're going to start in a couple of weeks, one of the issues we'll find out is we have to use the exact right level of Android Studio and the exact right level of APIs and the versions of the API methods we're calling and so on. There's a lot of complexity to juggle, even using the official tool set. So, how you would manage that if you were trying to use a sort of a home brewed, make it up yourself type of solution like Cordoba, I don't know of any sane person who would want to do that. So, once again, just quickly wrapping up this video, and if you stuck with me this long, thank you. But let's give a quick overview of all the things we had to say here. So, the question started with why use device specific dev tool stacks. And the answer is the memory map and the device drivers are going to be correct and working. And the other answer is in terms of product support and licensing, you're going to have no problems. You'll be all set. So licensing means that you have a licensed right. Say if I'm developing an iOS app and I'm developing it with Xcode and iOS and I've done all the right things, right? I want to get my product into the App Store and I want to monetize it and make money and all that. I'm doing everything right. Apple cannot possibly come to me later and sue me because they say I'm violating the end user license agreement. Are you allowed to use these sort of watered down public APIs for Xcode? To be honest, I haven't looked at the licensing. I suppose since they're put out by Apple, the answer is yes, but you're going to get an inferior experience. And if you're making a children's Pokemon game, you might not care about it that much. But imagine you were making something very critical, maybe potentially life support. You have liability as well, right? If you're a vendor of a software product, if you sell a product, the user is buying the right to enjoy the use of that product as you have stated that it's going to work. And imagine, I don't know, for an example, a delivery company or something is using your mapping app to get their trucks. The guys are using them to get around and find how to do the delivery. And if it starts giving the wrong addresses or something, are they going to come and sue you? Well, anybody can sue anything about anyone, about anything, I suppose. But my answer, if you're asking what I think, then my answer is definitely stick with doing it the official way, or go out and buy the MacBook, get Xcode, and use your official technology stack. Is there ever a time you would want to use? My system just winked out here. What happened? Did I lose my video? No, I guess I'm still okay. Uh, is there ever a time that I would want to use a simple HTML solution? Yeah, sure, there could be. I mean, if I'm just putting out brochureware, if I'm putting out a menu for a restaurant or something, and there's no interactivity, or maybe I'm happy with just using simple HTML forms. If I do not need to get to the device internals, camera, address book, shake sensor, tiltometer, or any of the other internals, then I would say a simple HTML mobile app solution would be fine. As soon as you need to start talking to the internals, go by the official product stack. And what was the other thing I wanted to say here? Oh, yeah. There is one other factor to bear in mind now. What about the case of React, right? React, because React, as you know, is mobile application development framework. And does that get covered off in all the things we've been talking about? And the answer is no, for a reason I'll spend a couple of minutes looking at. So here, React is kind of a unique situation because you are writing your application code in JavaScript. However, React does it as follows. See, here's how React does things, which is completely different than the original thing we started with, which is a simple HTML mobile device app using a tool like Cordoba. There might be other frameworks. I've never heard of any, but they could be out there, I guess. But here's the React situation. So, what is React? React is a JavaScript framework, which means you can write your application in ECMAScript 6, latest specification of JavaScript. You write JavaScript and you use the React libraries. And then you deploy, you load your app onto your mobile device. So it could be iOS or Android. Now, there's an intermediate step here you need to understand, which is that React consists of two parts, right? There is React, sort of the base React, which is a JavaScript library or JavaScript runtime, the React runtime. So the way that works, by the way, it's not totally JavaScript. It could not be, because JavaScript is it's an untyped language, right? It's not typed. It's uses something called weak typing. And to write a complex enterprise application like React, we would need objects. So therefore, the way it works with React is we start with our React with our JavaScript code. We do something called transpiling. This is part of the tool chain. If you're using Visual Studio Code, for example, and if you're using the npmjs.com library, see, these things are libraries in npm is like GitHub in a sense. It hosts libraries that you could use with, well, with JavaScript. With npm is a application development environment for JavaScript and TypeScript. So if I had Node.js installed, right? So if I had Node.js, I could start running this code, and in Node.js I could write JavaScript, and as soon as I start importing stuff that looks like this, I'm going to be importing the React library, and it's going to start running because it's a JavaScript program, so it'll run, and it'll get a JavaScript runtime up. It'll get a React runtime up and going on my environment, on my Node.js environment. And then when I start running my JavaScript, part of this tool chain is something called the Babel transpiler, and that kicks out TypeScript. So I'm not really running JavaScript on my mobile device. I'm running TypeScript, which is objectified, object-oriented JavaScript. But the point here is between my TypeScript code and my HAL, hardware abstraction layer, it's all in my book. So the HAL is something baked into the firmware of your phone, of any type of embedded computing device, right? Could be a Raspberry Pi or something, could be an Internet of Things device. But this is firmware. So with the highest level connection with outside, what I connect to when I'm connecting to my GPIO socket, for example, if this was an example of Raspberry Studio, of Raspberry Pi, or when I'm loading into my device, my phone, maybe I'm using a USB-C cable from a Windows machine running Android Studio, or maybe I'm using Xcode and I'm sideloading my iOS app onto my iPhone. However, I'm doing it, when the code gets in there, first it talks to the hardware abstraction layer, and then that presents a set of APIs that gets you down to the base hardware. And people have been doing things like this for at least 20 years now, 15 or 20 years, because in the late 80s and early 90s, there were a lot of viruses and cyber attacks that would involve going directly to the CPU registers. And that's why, even now in Mac OS, which is based on Linux, it's been that way forever. And in about the last 10 years in Windows, you cannot go directly to the CPU of your device, CPU registers, which is kind of sad in a sense because it used to be a lot of fun back in the old days. We could program using assembly code and we could go directly to the metal and do interesting things. And I can't really do that anymore because of protected mode. But the point I'm making is from your code, which you wrote up here, using your Node.js React library, and then you compiled it, and that generated TypeScript, and then you deployed it through various mechanisms. There's a number of ways to deploy, but the key thing I'm getting to is you have the React runtime, which is just React.js, and you have React Native Bridge. React Native Bridge. Now, this, in a sense, is like a bunch of device drivers. Remember, we talked about device drivers before. So this exposes APIs you can call up here, and on the other side, it reaches down and talks to the hardware abstraction layer. Now, why this is not equal to Cordova is these device drivers, these Objective-C, in the case of iOS, these Objective-C device drivers came directly from Apple. Apple made this. Or in the case of Android Kotlin, the Java native device interface, Android provided them. Android and the vendor, and I guess if you had another product next week that you want to put React on, the React native device, native bridge, comes directly from the vendor. It's based on the official memory map. Based on the official memory map. So that's why React is an okay thing to do, because in all cases you're respecting the memory map and the official device drivers. Right, so once again, and device drivers are always written in C. Why? Because high-level languages like Swift or Java, high-level object-oriented languages, are meant to be write once, run anywhere, which means they do not have pointers. Pointers is an old, going back to 1974, I think, when the first ANSI C specification was written. Pointers is a thing that lets the programmers go right down, even to a specific. If they're using near pointers, they can go to an exact memory location. Does that sound familiar? Like the memory location for your camera, for example, with pointers. And it's very hardware architecture specific. It's different for different architectures of CPUs and so on. But that's why we cannot write device drivers in Java or Swift. We need to use C, such as Objective-C for Swift, and for Android, it's Java Native Device Interface. They're, in all cases, they're little C programming languages. Right? You could not do that with object-oriented. Why? Because it wants to be write once, run anywhere, which means that I can write my Swift code and not caring about the underlying architecture it's running on, because the intermediate, the compiler, the Java C, for example, compiler, or the Swift compiler will take care. And again, just like the thing we were talking about before, which is the React Native runtime. The language compiler always has to be hardware architecture specific. Anyway, there's a lot of content here, and I hope that I managed to do a good amount of justice to that student's question. I think it's great. I commend that student for thinking about that, because I think students these days are perhaps a little bit too willing to be respectful of authority, in the sense of uncritically, without sort of stepping back and asking why something is. They just sort of, are too accepting of it, I think. And the employers at work, especially if you're in a development function, maybe a startup where you're developing new product, you definitely need to have the mental agility to step back a couple of paces, shift left a little bit, and ask yourself some good detailed questions like, how do things work and how do we need to change them to work better? So I'm looking forward to any questions about this in the comments, or whatever else. Just be in touch with me, and hopefully we can keep working on this till everybody understands it. Now, again, a lot of this stuff is in my book. So if you go and read my book and you still have questions, you can always go and talk to ChatGPT these days as well, I suppose. But the links for my books are right up there. All right, see you later. Have a nice day. Bye.